Well, for those joining us on the live stream, this is another episode in our continuing efforts to design the future of chemistry in Wolfram Language. So let's get started. Where are we starting? Are we starting the molecule plot, or where are we starting?
Well, at the top is molecule. We still have a few.
Okay, you're hard to hear, by the way.
Okay. Hopefully this is better.
Okay, no, you're better. Fine. Okay.
Right.
So what we talked about last time, what on earth are these?
So let's see. So for the bonds, we could have a single bond, double bond, triple bond, and they would have escape patterns that could become nice glyphs for infix notation.
Well, that's an interesting claim. Okay, so let's take a look here. So what you're imagining is that we start off with, okay, what is string key? What on earth is that?
So that's just an example, like that a person could give a string as a key, a label, a key, so that they can refer to it like that later. So
okay, fine. Okay, yeah. Fine. So the elided form is just the standard element abbreviation here, or alternatively the element entity, presumably.
Yes.
Like
or isotope entity.
Oh, interesting. Yeah, very good. Right. So something like that. Now, arguably, the canonical form of this should have entities in it. What do you think about that?
Yeah, that sounds good.
Seems sensible to me. I mean,
how do we do the second atom then that's carbon 14 as an entity?
I think we do it the way you would think you would do it. Namely, I think we can just, isn't this just going to work?
Okay,
yes.
Yep. Great. Okay, question answered.
But what doesn't work is giving a charge. I don't know that you can use entity instance to give a charge to an element
let's
entity.
Make that be true. I mean, I don't see any reason why we shouldn't make that true. Michael?
I think that's a little bit questionable. Actually, I already have, honestly, some reservations for the isotope, because the isotope does not refer to the full atom.
Like it doesn't refer to the electrons, it only returns.
Exactly. But you are mostly interested in the non-things inside.
I just don't think we should have strings hanging out there. I mean, we've got this nice canonical representation as entities.
But we don't have really a canonical representation of atoms as entities.
I understand. Carbon as an element.
It's quite different from carbon as an atom.
Okay. Well, should we have atoms as entities? Or is that going to cause other problems? I mean, it seems not. Okay, so let's imagine that we have, I mean, it is a complicated thing, because I mean, carbon as a bulk material is one thing. Go ahead.
Yeah. It is maybe a limiting form of entity instance. Like we can take 20 grams of carbon conveniently as an entity instance. And one could think of that once ENT as ENT as the new unit for counting things has been approved in the next years, that then it might be very natural to say an entity instance of carbon element with ENT goes to 1.
What the heck is ENT?
ENT is basically 1 over Avogadro constant. It's one thing. And it's allowed for atoms, radicals, molecules, and there's a long list of things for which it will be allowed.
Okay. What does it mean, ENT?
One entity of it.
Oh, okay. Interesting. Okay, fair enough. You have, I think, told me this before, and I had heard this before, but I keep on forgetting it, which is a bad sign. Okay, but let's
So I think an entity instance is a reasonable faithful representation of a single atom.
Well, so what are you imagining? Entity instance of the carbon, the material, or what?
Yeah, of carbon as an element, not as a material. Carbon as a material is yet another version. And then something like amount goes to one atom, basically.
Okay, I'm going to make the different proposal that we actually consider having atom entities. Is that obviously crazy? Maybe it's a silly idea.
What kind of properties would that domain have that wouldn't be element properties?
They would be. I mean, it would pretty much just go through to element properties.
Because one thing that occurred to me is I could set up a number of entity stores that ship with this packlet, and one of them would be an atom entity. So it wouldn't need to be an entity type in the Wolfram Alpha.
Who cares about that? That's just an implementation detail. I'm not worried about that.
Okay.
Black is a property unconvincing for a single atom.
Yes. But atomic radius is a very good one.
Allotropes is unconvincing for a single atom. Boiling point is unconvincing for a single atom.
Yep. And the hardness.
Yeah, I mean, all the bulk properties are unconvincing for single atoms.
Yep.
I mean, interesting, crust abundance is not obviously stupid for single atoms.
So as opposed to an entity, last time we met, you suggested having just an atom wrapper around an association. And if that were the case, that could format nicely. Like if it were an atom, atomic symbol goes to carbon, mass number goes to 14, then it would format as the C with a 14 superscripted beforehand. Same with formal charge.
All right, so we've got two choices here. We can either have, it's like we can either decide that an atom is a conceptual thing where we could in principle have an atom with, we should also have presumably an atomic number. If we have an atom, we should presumably have an atomic number thing here. We could imagine the atom with atomic number 150. Making sense? I mean, if we're going to go that direction, then we should allow ourselves the possibility of having atoms that haven't been named and aren't known there, or for example, isotopes that aren't known isotopes.
I like it a little bit more for two reasons. A, it's very parallel to molecule, and B, even if we would have atoms as entities, then there would be still differences between a freestanding atom in the universe and the atom within a chemical.
Yeah, you're right.
There would be yet a difference.
Well, so essentially we are turning chemistry into mathematics here in some sense. We're defining an atom as an abstract thing that has certain attributes, and we're not, and knowing the property of the atom, like for example, if we know its atomic, its atomic number, its mass number, that specifies what type of atom it is, right? But it doesn't tell us what its actual atomic mass is. Am I making sense?
Right.
And for example, in this case, we don't know the actual atomic mass.
Right.
Now, we could imagine that given an atom like this, that it would have certain properties like atomic mass, which when it is computable from things we know, we give it. Now, for example, we could imagine, is it stable, for example, is a reasonable question to ask given a mass number and so on.
So when you say atom atomic number goes to 12, and then you want the atomic mass, but you have not specified the mass number, do you give the periodic table mass of carbon, which is an average?
I think so.
Okay.
I don't think that's right for an atom. It should be C12 or C14 or C13 specifically.
No, but we don't know it. I mean, we've got the atomic number is 12, and we weren't told the mass number.
Okay, then it's missing or not defined at this point. I don't think we should give an average. I don't think we should give the crustal average. No.
Well, hold on a second. I mean, people most of the time are not going to give the mass number.
Right.
And most of the time, I mean, for carbon, it's a little weird, but for plenty of other elements, there are a bunch of known isotopes, and people routinely compute, molecular masses just based on the, the average isotopic abundance, right?
The average isotopic abundance is fine if you're in the laboratory and you need to weigh out so many moles by mass. For molecular modeling purposes, it's going to be one isotope. That gets tricky when you're dealing with bromine and chlorine, where you have two isotopes that are each around 40% abundant.
Well, so what do?
You have to make your choice at that point, which one you're going to model, or you model an ensemble of molecules.
Okay,
one with one mass and one with another mass.
Right. So let's take that as a for instance, okay? So what you're saying is that in the case of an iodine compound or something, that you're saying there are two different molecular structures that you will get depending on which isotope of iodine you're talking about. Is that right?
Yes, and depending on the experiment, you can distinguish them. Rotational spectroscopy, for example, microwave spectroscopy would distinguish chlorine 35 from chlorine 37 in a molecule.
Oh, what a mess.
It is.
So far with the molecule implementation, if you create a molecule and you ask for its molar mass, you get back what you would get if you added everything up from element data using the averages.
Using the atomic mass. Look, I think it's what we have to do. I think anything else is just going to be obnoxious to the user. Now, whether we generate, let's walk through this. I take this point, Bob. I take the point that there's something complicated here.
Yeah.
And that basically what has to happen, in the case of iodine, for example, who knows? Maybe it depends what part of the Earth you're on, which one, if they're really close in relative abundance. I mean, there are clearly other ones which are really funky, like uranium, for example, where depending on whether you're dealing with, you might be dealing with depleted uranium, for example, where, where it's been artificially, the abundances have been artificially changed. Okay, I take that point, but all right, so listen, let's assume we're going to do the atom wrapper, which is going to be beautified in some way. It's probably got to have its very own, non-yellow yellow box, so to speak, that represents an atom. Okay, so then what you're saying is we're talking about single bonds and so on. And you believe in the idea that, like two-way rule, for example, where if we said two-way rule, we would have that is something that has two arguments like that. And you're saying single bond is a creature like that. Is that your idea?
Yes.
Okay. And it's represented, it has some glyph, and you're suggesting an infix form for the glyph.
Yes.
Do we have a design for the glyph? Do we know what the glyph will look like?
Not yet.
So I think it should look like the undirected edge, and then double bond and triple bond would be like those, but with them stacked on each other.
What about an aromatic bond, Jason?
Well, so one straight and then one dashed underneath it, just like they're depicted in molecule plot.
Right. I think in general they should be fairly long glyphs, unlike the
unlike undirected edge.
Yeah, for example, right.
Yeah. So without a knob at the end either, I think.
Definitely. Okay.
But still clearly distinct from minus in that case then, or dash.
Definitely.
Yes.
Definitely. But we can do that by having, the glyph makers. So Andre is in charge of glyph making. Okay. Do we have any project manager for this project?
Not really.
Jason's been acting as that.
Okay. Well, so Jason, you'll need to chase down Andre Kuzniarek for the glyphs.
Okay.
And then in terms of the installation of the glyphs into the font, that's a whole other separate issue that goes through John Fultz. But you can, if you want to know, listen, you could ask somebody like Charles Poo about this because he's had glyphs installed for graph theory stuff. So he knows the procedure. Okay, then we got to go through here and, I would suggest certain accessor functions have got to work on Atom and others won't. And we probably should take those properties from the element data and isotope data. Okay, so let's keep going. All right, so we have these various bonds. And okay, now what on earth is this creature here?
So we've moved back and forth between having that in the second argument or into an option. It describes the.
No, I remember what it is.
Okay.
But I mean, why is so? When you describe a molecule, this is really pretty important to knowing what molecule we're talking about, right? I mean, this is like,
Yes.
if we have a graph and you fail to have this, it will be like saying, well, I forgot to put in, so I don't think it's an option. I don't think that makes sense. But now let's walk through what this actually is, because I can't read this right now. And maybe this should turn into an association that's a bit more readable. So walk me through what this means. So that means that we're indexing into elements of that list, right?
Right.
And we're saying around this center, in a clockwise direction, these things read in that way. Is that correct?
With the caveat that you need a direction in order to define counterclockwise or clockwise. So the direction is given, that you're looking is from atom 2 to atom 1.
How do I know that?
It would be the convention from the order specified, but if we use an association, we could specify those two particular atoms' references. Actually, the first atom stands by itself. We could choose one atom to be the fiducial atom, which in this case would be atom 1. And then the remaining, we would have a list of remaining 3 atoms that would be clockwise or counterclockwise.
Okay.
That's one way to do it. It's kind of long.
But I mean, let's just look at this for a second, okay? So, but we could display this when we display a molecule. Well, we're displaying the molecule as this molecule thing gets displayed as a molecule. I mean, the thing that I don't like about this is it's pretty cryptic. I mean, in other words, okay, if people are going to be seeing these all the time, they'll learn what they mean. But if people are only going to be seeing them, oh, whoops, my molecule has some weird stereochemistry. What on earth does that mean? And from the point of view of storage and memory, it doesn't make any difference. They're all
right.
efficient.
Well, the way it's handled pictorially in a two-dimensional diagram is generally with wedged or hashed bonds coming out from an atom and 2 straight lines for the 2 atoms that are in
I've seen those. Right. Okay, so just roughly, if you were going to write this out full form, explaining it, having the structure explain what's going on, what would it look like?
I would probably, if I were to make an association, I would say the first key would be center or atom or stereo center. And then it would, the value would be that particular atom, its index or its key.
Yep.
A fiducial atom.
What does that mean?
That's the reference atom that you use to define the direction at which you're going to look at the set of atoms.
Okay.
And then the third thing would be a list of the other ligands around the stereo center. So that key would probably be ligands.
Okay.
And then the last item would be for tetrahedral centers, we can say parity. That is sometimes used. And then we would say clockwise or counterclockwise for the value for that, which would indicate the direction that the ligands describe when you follow them in order, looking from the fiducial atom to the stereo center atom.
Okay, but now you're saying tetrahedral, but is that something we should talk, like stereotype or something? Tetrahedral.
Possibly. For phase 1 of this, we want to only handle tetrahedral centers or typical organic chemistry. Once we get into inorganic chemistry and we have 5 and 6 coordinate atoms, you still have stereochemistry, but it's not a binary relationship. It's not just an R and an S or a plus or minus. You can have different handedness, and there are several different arrangements around a trigonal bipyramid or an octahedron or a square pyramid that are different.
All right, so you just convinced me, just from what you're saying right now, that we need to be a little bit more careful here. We need to actually have a design that's going to generalize to the case of beyond valence 4.
Yes, we do. We knew we had to do that, and maybe having this stereotype is just what we need to do that.
And it will lend itself to the other type of stereochemistry that we support at the moment, which is double bond stereochemistry. So there you'd have stereotype goes to double bond or.
Okay.
Yeah. Right.
Okay.
And then eventually we should also be able to handle chiral axes and chiral planes, which are another whole beast. And I'm not sure how we want to do that, but this would allow us to do it.
Fine. Then let's figure out go ahead.
How much are these properties of real molecules versus property you can randomly describe to any molecule?
So most molecules you'll find, or not most. So a lot of times when you make something in the lab, you'll make both handedness, both parities in equal measure. But sometimes nature has a strong preference.
Yeah, that's not quite what I mean. Assume you have one that doesn't have anything, CO2 or something like this. But you now start kind of putting this into a molecule construct. Do you invalidate the structure? Like, is it still a proper, correct, valid?
I don't think most molecules don't have a multi-handed form.
That's my point.
Right. So I would prefer to issue a message and return unevaluated, and let them delete that bad.
So what
input.
aspect of a molecule? So given this graph structure, only certain atoms here are valid stereocenters.
Yes, that's correct.
And that's a computer property you can ask for. Like, say you don't give any of the stereo elements, you can ask undefined stereocenters, and I can tell you which ones are possible stereocenters and would have no handedness attached to them.
Or you could determine the handedness from the 3D coordinates.
Oh, that's interesting. Okay.
And they have to be consistent.
Fine. I think this is the way we should go.
But it kind of means we need something like a molecule Q.
Is it a valid molecule?
Yeah. Is it a valid version?
Yes.
Because the head is always correct per definition.
Yeah.
Right. So yeah. So I do have one hooked up at the moment, a molecule Q.
It's got it has a head of a molecule, but it isn't a molecule.
But the same is with region. You can say region A, B, C, D, and it's not region Q.
Okay, so here's where we're going to get into trouble. We can't have an atom Q because we've already got one of those.
Right.
Yep.
And what happens if we've got, do we consider it an atom? I mean, for example, let's say there's a mass number. Let's say the mass number is less than the atomic number, which is impossible, right? What do we do? One possibility would be to evaluate to something. Now that's crazy. Never mind. Go ahead. What were you going to say?
I was going to say issue a message to that effect, pinpointing the problem and return unevaluated.
Yeah, but we don't get to have a function that asks, is it a valid atom?
Right. So far, the atom only lives inside the molecule.
Yeah, just wait. They'll be out. I mean, some of these things okay. So, by the way, we got a bunch of background noise. Okay, let's go back to this. So, what we're saying. So we've got an atom, an invalid atom. Okay. Atomic number 100, 110, mass number 30. Okay, totally impossible. What do we do?
So I envision atom, the way we're describing it, as being inert, as not evaluating. But if we apply formatting rules to it, then it will try. Then at that point, it'll say this is
Okay,
Maybe
fine.
it could pink box. I don't know.
Yeah, or something like that.
But it's always a shame if you don't have a way to programmatically do something that you can do interactively.
Yes. Well, I mean, clearly, valid atom or something can return true or false. Just like,
It's actually probably a good idea, because it is probably much better than a Q function, because we don't have the tools to do the nuclear calculations if it's a valid atom. A Q would force us to make a decision, but we can't do it.
Yeah, that's correct. And the same with molecule, actually.
Yeah, correct.
Okay, so then, okay, well, I don't know whether valid is the right name. Maybe it's physically realizable. I mean, the real word is physically realizable. I mean, it's even beyond that, because, clearly, if we say carbon 100, right, that is an isotope in principle. It wouldn't last very long. Probably if you looked at the scattering phase shift or something for the 100 particles coming in, they would be I don't even know what would happen. Michael, do you have a nuclear physics comment on that?
No.
Yeah. Physically realizable, though, implies perhaps some aspect of energy or something like that you can create it in the lab. And yes, a lot of people recognize what we're doing here as models rather than real molecules, in a bottle.
Right. But let's take the atom case to begin with.
Mm-hmm. So we have a model for the atom. It has a mass number. It has an atomic number. They have to satisfy certain relationships.
Well, but there's a different thing, which is, okay, so there is a much easier test, which is known atom type.
Yes. Yep.
That's fairly easy to answer.
Maybe also with some reservations. I guess there are many nuclei that are known, but it's not clear if they ever had time to form an atom.
That's true. Well, so that's again subtle. So I mean, basically, what we need is an accessor there that represents, for both the atom and the molecule case, that represents maybe the different conditions that could be the case. Like, for example, one very clear one is stable atom. Right? That's a definitely answerable thing.
Mm-hmm.
I mean, another thing that you could ask for would be entity, and it will return either the isotope or element entity.
Yeah, fair enough.
But one thing, so determining whether these things are valid or not doesn't necessarily determine whether molecule could eat them. So presumably they could contain blanks. I mean, at the moment I haven't hooked that up, but they could.
What do you mean by blanks?
Atomic number goes to blank.
Oh gosh.
But I haven't hooked up queries, molecule patterns yet. But
okay, well that's a separate issue. That's the pattern atoms, so to speak, as a separate issue, which we need to deal with. I think the answer to whether an atom with a blank there is a stable atom is it's not, or it's not determined. I mean, the correct thing is probably that it's not determined. All right, let's keep going here. And I think that's a good solution to that. Okay, so single argument constructors.
One other thing I'd just like to touch on there. If a user enters, atomic number 6 and does not specify the mass number, would we assume then that it's the most stable one?
Well, that's what we're pushing earlier. I mean, I think that that the alternative would be, okay, so here's an interesting possibility. Okay. We say atomic number 6. Well, let's take what's iodine. I don't even know what's well, whatever it is.
That's carbon.
I know that's carbon.
Oh, okay.
That part I know.
Okay.
Helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Oh gosh, it's going to take me too far to get to iodine.
We won't make you sing it.
Yeah, right.
Rory could.
Yeah, so could my youngest child. It's Okay. So, okay, but what I can imagine here is that we do this. Now, if you then want to do molecular modeling, there are certain things that would then not work. But if you're doing, molecular mass type calculations, that's going to be just fine.
Right. I think it's important if somebody take caffeine as a molecule, and you ask for its molar mass, it should give the same thing that the entity gives you.
Definitely, which means that's got to be natural abundance. Even if then what has to happen is, if you've got things with natural abundance, which is what you probably get if it was defaulted without a mass number specified, then, one thing that's unfortunate about this, okay, so in a perfect world, this would be some kind of discrete distribution. Actually, no, it will be a weighted, what would it be? It would be some kind of weighted data type thing where each of the actual numbers would have an appropriate weight.
Right.
That's the correct form for this. And this would just be a shorthand for that. And given this, if you then try to do molecular modeling, your basic claim is we can't do molecular modeling unless we have a definite. Well, I don't understand. Okay, let me ask you.
I'm not saying that you can't do molecular modeling. It's just that depending on the type of modeling you're doing, one use of the mass versus another changes the result.
I understand. Right. So the stupid thing to do would be to say, if the if it's 12.2 is the atomic mass. Look, there are two different issues here. One is the mass number is not the atomic mass, even independent of because of the mass defect and so on, because of the binding energy, right? Mm-hmm. So there's one calculation is what is the actual mass, and the other calculation is what is the mass taking into account the fact that the mass number may be variable. So so the stupid thing to do would be to say the effective mass of the nucleus or the atom is 12.2 when that is the thing you get by averaging over multiple isotopes. Right. Now, I don't know whether people actually do that, but maybe that's just a dumb idea to do it that way.
Well, so you put natural abundance there, and it would default to the element atomic mass on the periodic table. Another thing that you could write there would be, this is probably the wrong name, but commonest or most common.
I see what you're saying. Yeah, that's a good idea.
Yeah. And that would be good for molecular modeling in terms of spectroscopy or something like that.
Well, so then maybe the right thing to do is to say mass number arrow automatic, and that's the default. And when it's computing molecular masses, it does it by natural abundance. And when it's doing the modeling, it does it by commonest.
That sounds good. As long as, I think we can make that workable.
Right. So when we give the moment of inertia tensor, it's using the specific isotope masses. But if we give molar mass, it's what they expect. Right. Okay.
Right. And if you don't like that, then you pick atoms that are more specific.
Right. For a per deuterated compound, for example, all the hydrogens would have, mass number 2.
Right. Okay. I think this is good. All right. Let's move on. Single argument constructors. Okay. Is this unique? The smiles cannot be the name of the molecule. Is that correct? In other words, it seems unfortunate to not be able to type molecule of water.
I agree. So if you type molecule of water, but you mistype it, how can I, if I don't know what you meant it to be, how can I give a good message? Like how do I know if you mistyped a name or if you mistyped a smile string?
Are smile strings readily recognizable? Very.
Well,
to a human, they're very recognizable. I'm sure we could train. I wouldn't worry about the mistyping thing. If you mistyped it, you're on your own. Remember, it's going to have autocompletion, right? So it's going to be challenging to mistype it, right? So we need an autocompletion table that works for both names of molecules and smiles.
I don't think we can do the latter.
Why? We just take common smiles and we autocomplete to them. If you're typing in something which isn't a common smile, then keep typing.
That table will be millions long.
Okay. Well, I mean, so maybe it has to go to the server to figure out. I mean, if you're typing, okay, that is an issue. I mean,
well, if you're typing a hydrocarbon, Stephen, how do you know when you're going to stop?
You absolutely don't. But autocompletion is not a mandate. Autocompletion is a suggestion.
Right. And so you've typed 4 C's in a row, and that's butane, and then it's going to suggest pentane, hexane, heptane, ad infinitum.
Well, it probably won't, because it knows a certain probability distribution for these things. So, I mean, it's not going to keep suggesting them forever. It's only going to suggest the common ones. I don't know. That's
okay. It's an interesting thought. I hadn't thought about it before.
I mean, the alternative is, if it thinks you're typing a smile, it doesn't auto-suggest anything. It just gives up on the auto-suggestion, which I think is also okay. And we only auto-suggest common names.
Right, and especially if it's mixed case like that, it'll be easy to tell because, Smiles does use lowercase letters. It won't look like a word.
Right, but the generic name, so generically we'll assume it's a name. Is that right? Even if, but you will be able to qualify it by saying molecule. You'll be able to say this is definitely a name by saying name arrow C,
right.
C
yep.
colon or something, or whatever it is. Name
yes.
no.
And then you could do the same by saying Smiles arrow and then give the Smiles string.
Yeah. Okay. Fair enough.
Or Inchy, or peptide sequence or nucleotide sequence or something like that. And that's what these other bullets are for.
Okay. Sequence of amino acids. So those are specifiable by random letters of the alphabet, right?
I think there's a small subset of the letters that are like, so those are the single letter keys.
Yeah,
right.
But there are 20 amino acids, so you can't get away with much less than the letters of the alphabet.
Right.
I mean, for the bases, so I don't understand what, I mean, I would have expected that this would say something like DNA sequence, arrow, something like this. Why would that not be? You've got to say whether it's 5' and so on. Is that right?
Right.
And that also could be interpreted as a protein sequence.
Well, fair enough, but I don't think you should do sequence and then a type. I don't see why we shouldn't just have, because I think they're going to be, just have these things and then sequence arrow, because the left-hand side is perfectly identifiable.
Yes, that's fine by me.
Okay, so what about the 5' versus 3' business? Or is that the only thing you need to specify for a DNA sequence to know what molecule it actually is? No, don't you need the end caps and weird stuff like that? I mean, the thing isn't a real DNA sequence, is it? If it you can have a, okay, this is showing my lack of knowledge, but when you have a fragment of DNA, does it need end cap? It needs end caps, right, to just hang out there. Otherwise, it unravels, doesn't it?
This is also outside of my usual area.
Of my scope, also.
All right. Okay. Well, I'm pretty sure about that. So, I think an amino acid is, a protein is different, and that's fine. But I think what we want to do there is, I mean, you're assuming that they're all. Again, I don't even know whether you can mix left and right-handed amino acids and so on.
Bacteria do.
Okay.
Jason and I were talking about this earlier today.
Well, fine. So we need some kind of indicator then. That's going to be a little bit of a mess, right? We'll need some kind of indicator. So it's no good to just say L amino acid sequence or something.
No. We'll check the IUPAC rules for these sequences and,
Okay,
and
fine.
the notations that are used.
Okay, let's keep going here. Include hydrogens.
So you made the point that often, I mean, surely they would just be there and it would be a plotting or display option, but oftentimes people do want to have, in keen informatics, want to have just purely hydrogen suppressed graph. And so that wouldn't be the default, but it would be.
Well, so what is the default? The default is include hydrogens. The default is what?
All.
What does that mean?
That there are no implicit hydrogens. They're all actual vertices in the list of vertices.
Fine.
Automatic would be, there are some cases where you need you need a hydrogen in order to fill out your valence, but the rest can be implicit.
Okay, fair enough.
And
now,
so this gets away with, previously I called it the Kikulize option, and so now it's aromaticity model. Whether you detect aromaticity or whether you mark them as single, double, alternating bonds, and then we could supply some more subtleties as to the aromaticity detection.
right. By the way, someone on the live stream is asking how feasible is it to train a classifier on different chemical format string types? Absolutely feasible, except that it has some, in the case where it's just a single C or something, there's multiple answers. Now, they might all agree in the case of multiple answers. That's an interesting possibility. I don't even know. I mean, in other words, are there puns between smiles? Is there a pun, between smiles and inchy? Is there a smile string that is also an inchy string, but they mean a different molecule?
No, so inchies always start with inchy equals, and so we could detect that right off the bat. I imagine you could come up with something that is not a chemically feasible molecule, but is a valid smiles and also is pronounceable. But it doesn't.
Okay, but I mean, in general, to be clear, in general, people's major escape valve is using our whole natural language stuff where you just are typing in, I don't even know whether you can give me a smiles to type in. I'm just going to make up what I imagine a smile might be, and I might be completely wrong. And that's probably going to conclude something completely different. But okay, whatever.
The problem there, what we do in alpha is you have to type in smiles first, or else the math parser really goes crazy with some of these big things.
Oh, cool! Wow, there I am. This is an actual chemical. Okay, but so then I see. Well, so that's a separate issue. Is thinking. We don't have to address this issue. Let's see how the UI looks, because in the auto-suggest, we could end up with something like, for example, when we type RGB color, right, we're getting a more sophisticated autocomplete there, right? See that thing? A choose color autocomplete. If we really think this is important, we could have a whole elaborate thing here. I mean, we could even have something there that allows you to start drawing molecules and so on. Am I making sense?
That would be fantastic if we could do that.
Right, but I mean, so we can pull up this kind of interface, right, to choose colors. So why not have an interface that allows you to draw the molecule, in principle, if we had such an interface? And that would allow us to give an escape valve to do much more sophisticated, natural language parsing if we need to.
Yep, it would be something like the graph edit.
Yes, right. Okay, so meta information, user supplied association, fine. We've got that in other places. So I have no idea what any of this means, but aromaticity model sounds sensible to me. Okay, coordinates. Let's take a look at that.
So it's inherently going to be a little trickier than graph because you're interested in both 2D and 3D. One option would be to say that a molecule can only have one set of coordinates and it's either 2D or 3D, but that seems limiting.
Silly. that's silly. You might want both possible displays.
Right.
I mean, the 2D coordinates are schematic.
Exactly. Jason, that's the term we need to use. Instead of
depiction was what I was saying.
Depiction, schematic is a better word.
So schematic coordinates?
Something like that.
Well,
okay.
I'm not sure that that's quite right.
And I don't think vertex coordinates right, even though that's the chemical data property for the 2D coordinates, because in graphs.
We probably should change it. We can have an additional property without any trouble.
Schematic is the right adjective.
Okay, well.
But it has connotations of an electronic circuit.
Indeed. Let's see. Do we want to say coordinates? Is that even the right term? It's not really coordinates. It's atom positions or something, isn't it? Because what are the, where's the 0? It's some kind of atom relative positions.
But we're not giving the relative, like the internal coordinates. We're putting it in space.
Well, I understand that, but where's the 0?
When we generate the coordinates, we put the 0 at the center of mass.
Okay, fine. So you think then that that's a reasonable coordinate system? What about the rotational aspect of the coordinate system?
So you can canonicalize it by taking the principal axes and aligning them with the Cartesian axes.
And then a few other rules on top of that can be applied as well for symmetrical molecules.
Okay, so there is a canonical coordinates. When if we said canonical coordinates, it'll remind one of quantum mechanics and be totally confusing. But
you want them to be able to move them, to do a geometric transformation and change those coordinates so that you could show two molecules together.
Yeah, that's especially important when you're trying to dock a small molecule into a receptor or an enzyme.
Okay. All right. So then there's an atom coordinates that is, and so now the issue is, what would it be called? What do you call the 2D diagram?
We typically call it a structure diagram. As an organic chemist, that's what we would call it.
And that's the chemical data property for the picture. Okay. Yeah, I like that. It's clear what that is and what the difference is.
So could we say structure diagram coordinates then?
Yeah, that's what I'm suggesting here.
Okay.
All right.
Yep.
What the heck is a random seed? That is scary as heck.
Users might want to generate a different structure.
Okay, so we've got this option, random seeding, which is the thing that determines how that works, right? We've used that in a bunch of other functions.
Mm-hmm.
Okay.
That would be the option for a stochastic method to generate the coordinates.
Right, but notice these three cases, right? It's either automatic, which means it's reseeded every time it's called, inherited, which means it's using the stream of randomness that is defined by things like block random on the outside, or it's using an explicit seed. Does that make sense?
Mm-hmm.
And that's quite useful because being able to do it, you want all of those cases.
Right, yeah, no, we do.
So I believe that there's a case is it in the neural networks where when it says it has an option, I don't know if it's random seeding or if it's a string valued random seed, but it specifically says what they use, that in order for reproducibility, when I called my library to generate these.
Yes, that's right. That's what, I made a big fuss about that because that was all confused. I mean, it's a little bit weird. I think we use 1, 2, 3, 4 or something.
Right, I used
2, 3, 4, there we go.
Right. Okay. So I could switch to using that. I use 42 because of the Hitchhiker's Guide, but
it's cute. But I would use 1, 2, 3, 4.
Okay.
I think it's much clearer if you see 1, 2, 3, 4 in the output. It's kind of it's just some 42. You might get confused. It's some atomic mass of something. It starts spinning out of control. Okay, so what is this? This is atom coordinates to automatic. What is atom embedding?
Well, so in graph, they have two different options. One, vertex coordinates when you specifically provide them, but then there's graph layout, which graph layout's going to have a lot more methods, a lot more named methods than we will. But you could give options to the embedding.
What do you mean? Well, why are we calling? So wait a minute. The atom coordinates, if you don't know the atom coordinates, there's two cases. Either you know them or you don't know them. Well, you might know some of them, but not all of them.
Right.
But why don't you just have a way of specifying atom coordinates, either that you know them and it's some particular thing in picometers or whatever it's in, and is it in picometers or what?
Well, that's where we're using coordinate array or quantity array.
Okay. So it is in picometers.
Angstroms is the normal.
Okay,
Angstroms is the,
okay.
Yeah.
So much for SI. Did SI give up on that, or is SI still fighting for picometers?
This is declared to be compatible for right now.
Okay, so we'll wait another 50 years.
Chemists just want the bond length to be around 1. So put any options for the generation of coordinates use the same option value, atom coordinates. It could be.
I think so.
Okay.
I think so, and I think as it canonicalizes, I mean, what is going to cause it to jump to actual coordinates, to computed molecular, modeling coordinates?
So they're lazy. So you would have. So if you create it and you don't provide them, and you just end with a semicolon, we haven't computed them yet, and only when you ask for them do we compute them. Is that what you're asking?
Sorry. I spaced out for a second. Could you repeat? Sorry,
so the atom coordinates are instantiated when you ask for them, when you display it.
Okay, but are they then stored after that, or not?
So we would like them to be, but I don't know how to do that because that implies making it mutable.
Well, not if they're cached.
Well, so they're cached, but then they're cached within the kernel session. But then if you quit the kernel and start over, you're going to have to recompute.
Well, in that case, you've got to return a different molecule, right? You've got to have something. Then we've probably got to have something that says, what's an analogy to this? Where, I mean, there is a strange analogy. There is a thing that we just added for neural nets, for recurrent neural nets, called, this is a little bit of a different thing. It's a net state object, where it's used for reinforcement learning and so on, where the thing learns by doing, so to speak, where it changes. Okay, so that's another issue. So we got to have some function that computes stuff with the molecule and returns a new molecule with things computed in it. We don't have that issue in graph, because we think we can do the graph layout fast enough that we don't need to bother to cache it. Is that correct?
That you don't have to cache it across kernel sessions. I assume that they cache them within the...
Don't know. You should ask. I don't really know.
So Michael and I were just talking today about wanting some function that would instantiate all the ephemeral options, but we couldn't come up with a name. But Michael was...
Yeah, I understand. I mean, that's...
I mean, we also don't have much precedent for this behavior in the system. Also, I think there would be places where we could make use of this.
Yeah. To instantiate the canonicalized form of something. I mean, we could always have a canonical form. Yeah, blah. I don't like it. Canonicalize. Blah. I don't really like it.
So essentially, you want to take every option that was going to automatic, and so you want to have like a real absolute options, which doesn't.
Yes. I mean, but absolute options just
absolute option values or something.
Change the object.
What's that? No, it doesn't change the object. It does not return a new object.
Exactly.
Well, I mean, canonicalize is a beginning of that, but I think that in some cases, we're not going to get that resolved today. Bring that back next time. Let's just keep going here for a moment. I'm going to have to unfortunately go again. Do we still have a chance to discuss this tomorrow, or are you guys off by tomorrow?
I'm off tomorrow.
Okay. Well, let's see how far we can get right now. I do unfortunately have to go soon.
Yeah.
So as far as formatting goes, Itai said it's not really possible to make something like a summary box, but without the molecule. But I do believe that by release, I should be able to work out the code for the attached cell. I really like the interactivity that mesh regions have with that attached cell, and so it seems possible.
In the cloud.
Okay. I do not know.
Yeah. I mean, so your proposal then would be to actually return essentially the molecule plot as the displayed form of a molecule. Is that right?
Right. And then one of the options would be to say, turn this into a 3D plot, or to...
well, then there's molecule plot 3D would presumably be the 3D version.
Right. But when you're just interacting with the object itself outside of the plot, you could switch from 2D to 3D form.
Hmm.
I mean, another thing we were thinking was you could have it display as a summary box, but then have a chemical form / chemical form, and it would give you a more interactive object.
Well, I have another question, which is, I mean, I'm not in this business, so I don't know whether when you see this, okay, you see some big molecule, it turns out to be caffeine, but you said molecule of quotes caffeine, and out came this big complicated structure diagram, right? Do you then say, oh my gosh, that's really useless, I can't tell what that is, I'd prefer to just see the word caffeine, why did it have to show me the structure diagram, instead of just showing me caffeine? Now, I could also argue if I type in 2 to the power 100, it produces an actual number, and you might say, well, it'd be more useful to see 2 to the power 100 than to see this long number. But my question is, if you're a chemist and the thing just produces the structure diagram, do you say, okay, great, that's a nice representation of my molecule? Or do you say, oh, I was missing the name?
So with the name, do we store that name? Should we put it in the meta information? So right now, if you say name goes with adenosine triphosphate, I convert that into a structure and then throw away the name.
Well, but if I ask for the name,
right. So I could put that name goes to that in the meta information.
I would.
Okay.
I mean, I think that, well,
I think that's a good idea for most cases that people would be using it for. And if they start to edit the molecule, then the name might become questionable.
And they could at that point say mol meta information unset if they wanted to.
Yeah, or they, yeah.
I am going to have to go, unfortunately, Drat. I would love to continue this.
Yeah, we've made a lot of progress today.
This is a beautiful thing. I mean, this is going to be fantastic. I want to see some of these things. Wow. This is really cool. So once we've got this design stuff straightened out, how long until you've got this fully implemented? I mean, is the underlying structure here basically implemented and we're doing some cosmetics here, or is there a lot of underlying structure that still has to be built?
A little of both. What I've written so far is flexible enough that I can change the design, but I've left some things in the air because waiting to nail down the design to really flesh them out.
Yeah, I mean, this stuff here, I'm not, I don't know about. And I also, another question I would ask is, when you have multiple molecules, like you talked about, docking of molecules, how are we representing that? What is is there some kind of molecular cluster thing that represents, like the analog of I don't know what the idea would be, but boy, you've got two molecules and they've got coordinates, atom coordinates that are relative to their joint center of mass or whatever else it is.
Right. We certainly, I mean, the object can support having disconnected structures in one molecule
so
object.
It says molecule, but really it's actually this drug binding to this particular site.
Right. Yeah.
But it would be nice if there were some kind of scene or something like that you could.
Well, it seems a little weird when you've got 10 water molecules dancing around, and it's the overall thing is wrapped in a molecule.
Right, and especially in the phase 2 or 3, when we can hook up some molecular dynamics, and you make a box and you put 1,000 water molecules in it, and you put your protein in it. Certainly, that thing is not a molecule.
Yeah, maybe we could use ensemble. I don't think that's used in the system anywhere.
It's not, but I think ensemble, for the
implies statistics.
Yeah, right. It implies,
It does. The other thing that those might be called is, if it's water molecules, it would be called a cluster.
Yeah, right.
Or gas molecules, but with like a protein and ligands, or a protein and some small number of water molecules that are hydrating the active site, for example. We do need a container for that because, strictly speaking, it's not a molecule.
Right. But so, look, the point is that this is similar to what happens in System Modeler, where you have multiple, mechanical thingies. And I don't know how that wrapper works there, but that's what we should be looking at.
Yeah, I can talk to Patrick.
Right. Fine. Okay. This is looking really lovely. I mean, I'm very much looking forward to the next step. I assume next week everybody is out. I'm actually around, yes. So okay. Oh well. All right. So I guess this waits for the new year. But if you want to, it's conceivable we could do some stuff without Bob, although I would prefer not to. If it's holding you up, Jason, we should do that. But if it isn't, then let's wait for Bob to be back.
Right. I can spend next week kind of implementing this, and there's some code cleanup that I would want to do. And if I have questions, I can start an email list with the 4 of us on it.
Fine. Sounds good. All right. Look forward to the next step here. Maybe we should try and schedule at least an hour and a half for the next meeting, possibly even 2 hours. There's still quite a bit of complexity here.
Right.
Okay. Okay. See you guys soon.
Okay. Thank
Christmas,
you.
etc. Okay.
Bye.
Bye.
Bye.